Everyone. Today I'm going to share with you all a kind of unique requirement that I had received from one of my clients and how I have modeled that requirement into the IBP planning template and what was the requirement and what was done to achieve that requirement. So the view that today you are seeing here is not a traditional IBP planning view wherein you generally have your time periods or the time horizon in the rows and the planning objects vertically in the columns. The client requirement was pretty unique, wherein they do allocation planning, which is kind of a heuristic based planning, but they do allocations based on ending stock and days of supply from different sourcing locations. And the unique part of that requirement is the allocation planning process that they do today, they do it from a shipping location point of view rather than from a receiving location point of view. If we talk about general heuristics and how heuristic runs is primarily the heuristics works upside down from a demand receiving location to the sourcing location from where the replenishments are sent into the downstream from the sourcing location back towards the demand location. Now the planning process or the allocation planning process here is primarily done by looking into both the aspect of the supply chain at the same time. What I am having in the demands, in the demand facing DC, what are my supplies, and based on the net demand or the net shortage that I calculate, I want to decide what am I shipping and how much quantity from the respective sourcing location. In order to map this requirement, the first and foremost thing was I need to make sure that both the product location and location from view and the product location to view are clubbed in a single view or single planning template. So the way this solution has been designed, if you see here, here in the columns, I am having the time horizon and I am having the key figures or the planning object at the rows. So time here is a vertical and the key figures are here in horizontal, which is just opposite of a traditional planning view. Now, as I said before, I had to ensure that both the location from and location to views has to be clubbed into a single view so that the planners can take a look at the receiving location demand and do allocation by sending in the required quantity from the shipping location. So if you carefully look into this planning view, we will see that I am having a DC, which is a demand facing location, where a certain SKU has certain demands. And this product location combination has primarily two sourcing options. One is warehouse 1 and warehouse 2. Now, point to note here is warehouse 1, on the other hand, is a hybrid location. When I say it is a hybrid location, I mean that this warehouse act as a both replenishment location as well as a demand facing location. So this warehouse primarily replenishes certain DCs like this DC1, and at the same time this warehouse also have its own independent demand that it fulfills from this location to its customer. Now the objective here is this product location combination, although it has two source of supply or two sourcing location, by default everything is supposed to be sourced from warehouse 2. And after that, planners need to have the ability to take a look into this stock position at both DC1 and this hybrid warehouse And based on the stock position and the days of supply that this warehouse one have, they can primarily adjust the sourcing request from warehouse 2 to warehouse 1 either in full or partially. So I am looking at the demand side, and at the same time I am also looking at the supply side, because I will be adjusting my sourcing request from a location that is shipping to a ship location which is shipping to DC1, whereas the demand and what other stuff that I am viewing here is at a product location, which is kind of a location from, where the DC is the location and your warehouse 1 and warehouse 2 becomes the location from. Now if you look into this view carefully, when I'm talking about warehouse 1 and warehouse 2, these are the shipping location. Now if you notice here, you will see this shipping location are primarily the lock ID here, whereas the receiving locations are nothing but the lock 2. So if I show this to you, you will see that these locations are all location type with a lock 2. That means this view primarily I am viewing all the key figures in a product location 2 level, whereas I am also seeing the demand and the supply availability of the receiving DCs, which are nothing but location 2, and transforming the values of the demand, on hand stock, in transit, from a product location level to a product lock 2 level, so that in a single view I can have the product location view of the receiving location and the shipping view from the location 2 level. So if you take a look into these key figures, these are all the available key figures within this planning view, which I have broadly segregated into two different sections. This section represents the key figures that are primarily representing DC1 or any location that are in the column B, which means these are key figures associated with lock 2 levels, product lock 2. Now, as we know in standard, be it demand, be it on-hand stock, they are all at a product location level. Whereas POs in transit, these are by default at a location from level, because we generally view them at a receiving location end. Hence, I had to do quite a few attribute transformations so that I could bring the demand, the on-hand stock or the initial inventory or the in-transit, which is equivalent to my, let's say, min transport key figure. I have transformed all of these values to its equivalent prod lock 2 level, and using attribute transformation, I am dynamically populating those values here at a product location combination, where the location is nothing but a log 2. Whereas if you see the other section where I have these key figures, which are primarily associated to the sourcing locations, in this case warehouse 1 and warehouse 2, these key figures are nothing but my standard downstream key figure, which is this OPT requirement is nothing but the transport DS key figure. Quantity update is nothing but the adjusted transport DS key figure. So primarily I am viewing all the downstream key figures for all the shipping locations, and I am looking at the receiving location value by doing an attribute transformation from product location or product location from to product log 2 level. So how I look into this, how planners look into this is, if you see here, this product, this location will have an initial inventory which is reflected in your on-hand stock, will have in transit, will have PO, This will have its demand, and based on that, this will be my ending on hand or projected stock. And also, I will have my days of supply or the coverage. Apart from that, I had two custom key figures here, what is called the net requirement and the estimated arrival of a request. So once I run the heuristics, or once the heuristic is run, this location, as I said before, this product location combination can be replenished either from warehouse 1 or warehouse 2, wherein I have defaulted warehouse 2 to be the default source of supply. So once the heuristic has run, all the supply request or the shortage that this location have has been requested to be shipped from warehouse 2. Hence, for warehouse 2 in the transport supply key figure, you see the numbers which are primarily saying this is what warehouse 2 is shipping to DC1. So if you see here, 278 is what they are shipping today, or what they are shipping in the month of February, and based on a 2 months of lead time, that will be available to replenish the demand of April. Similarly, with the case of 194, 169, 180, 105, 117, and so on. Now, this is a system generated plan. Now, what planners want is after they come to their system, they will see what the system has proposed from a default sourcing perspective. After that, they take a look at the inventory position of the alternate sourcing or warehouse 1. And if they see that warehouse 1 is having well sufficient stocks, or it is having good amount of safety days of supply, based on that, what planners might do is they can do a sourcing adjustment. So for example, if you see here in the month of October, I see that based on the present supply demand position, warehouse 1 will have a positive ending balance of 644, which means I will have 644 on my hand as on October 2021. So what planner can do is, planner primarily can see, okay, 180 is being shipped from warehouse 2 in the month of October, which has a lead time of 2 months. But since I have a ample stock of 644 available in warehouse 1, and the lead time between warehouse 1 and DC1 is 1 month, they can manually adjust the sourcing from warehouse 2 to warehouse 1. And in order to do so, what they primarily do is, if it is a full adjustment of sourcing, they simply put the equivalent amount of 180 here and mark this as 0, so that when I run the heuristic for the next time, the system is intelligent enough to understand that the sourcing for this 180, which was earlier proposed to be shipped from warehouse 2, has now been shipped, will now be shipped from warehouse 1. And this shipment has moved from here to here, and hence I don't need anything here. So I am marking it as 0. So this key figure, where I am manually putting the allocation number, confirmed quantity, is nothing but a custom developed key figure, which is very similar to my adjusted transport DS key figure. After planners maintain this and do the calculations and save it, even before they run heuristic to see the net demand change and the ending balance change, we have given them the feature that after they manually do the allocation, they can primarily put the allocation numbers and adjustment and save it. Once they save it, this custom ending balance key figure, which is the projected ending inventory, will dynamically reduce the stock of warehouse 1 by 180 in the month of October. And since I have a lead time of 1 month, that means this 180 that I am shipping from warehouse 1 in the month of October will be available in the month of November at the receiving location. It will increase the ending on hand of the receiving location. Thus, even before running the heuristics, planners can dynamically see the changes on the projected stock or the ending balance at the supplying location and at the receiving location, and based on that, they can do their allocation planning and allocation adjustment. So this helps them to get rid of running heuristic multiple times for doing this sourcing adjustment, so that even before I run the heuristic, I can see whatever my ending balance present position is. And after I have done, I planners, after they have done this activity for n number of products or multiple combination and save it, they run the heuristics for one time. And before the heuristic runs, basically this number gets copied to this key figure called quantity update, which is nothing but the adjusted transport key figure. So this value primarily goes and update itself here using a copy operator. That is also a part of the application job that the planner will run. And once that happens, now I have updated this same quantity value into the adjusted transport DS key figure. And the next time when I will run the heuristics, the system will consider this as the fixed supply from warehouse 1 as 180, and the fixed supply that was previously proposed as 180 from warehouse 2 will be converted to 0. And hence, I am again rebalancing and recalculating my supply position using the heuristics. Now, as I was telling to you that there was a lot of attribute transformation I had to do. Apart from that, there are a few more things that I had to take care of primarily is, if you see these key figures which I was telling you, these key figures are nothing but the standard key figure transport DS or transport supply, adjusted transport DS or adjusted transport supply. And this key figure has standard name and description. Obviously, we can go and change the description and the name as we like. But here, in order to fit so many key figures into the standard width of the Excel, I did one more level of customization wherein I have used the option called member names, wherein I have the option to select key figures and give it a new name or a desired name or nomenclature through which we can make sure that the description of the key figure is something that makes sense, and at the same time it is short enough so that all the required key figures can be viewed in the default view. So if you see here, this is the transport supply key figure of the transport DS. This is the confirmed allocation plan key figure or the adjusted transport DS, and this is the custom EA adjusted transport DS key figure. I have selected all these key figure here in the member names and have given it a new nomenclature, and this nomenclature have been saved. And hence, even though this key figure has a different name and description in standard, still I have manipulated the description so that it fits into my vertical requirement here. And in order to give them a clear segregation of the views, I had to use EPM formatting to group this set of key figures into two broad segments. This set represents the key figures for the DCs or the location that are on the vertical side, or per se the log 2 location type, whereas these key figures are primarily categorized and then subcategorized based on the sourcing location, which is the log ID in this case. And so for this purpose, what I have done here is I have used EPM formatting, wherein I have primarily marked for this location source what are the location source, and against this location source what will be the EPM formatting that I need to do. So if you see here, what I have done is I have used a multiple selection option, wherein I have grouped them with an union option and selected that if the source location are X or Y, then based on that, all the key figures, all these key figures should be grouped under the same tag, and they should have the same kind of a formatting so that planners can get to understand what represents what. Now, the reason behind having this view developed was planners today uses a very similar Excel planning sheet that looks very similar to this, and the company is going live with IBP for their allocation planning purpose and wanted to have a uniform planning view across all the planners, and at the same time they wanted to ensure that planners can get the look and feel of the old template that they are so acquainted to use for such a long time. Hence, the requirement came in, and based on this, I had to design and customize this planning view with EPM formatting, with member names, and obviously with attribute transformation. So this is the first part of this section, and the second term video I will all show you what are the different configurations and details of attribute transformation that I had done in order to achieve the request. Thank you. Thanks a lot.